Okay, so just as a starting point, I realised at the very start I didn't end up actually introducing myself, which is kind of poor of me, so I apologise for that. So my name's Jerome, JB. I'm a principal consultant with Mantle Group. I spend my day kind of doing this, that, everything else. I've been involved with CI/CD and pipelines and automation for decades now, it feels like, and yeah, have managed to do the Pokemon thing and catch them all when it comes to GitHub certs. So quite happy on that side of things. My contact details here, again, as I mentioned, lots of QR codes around. So my GitHub and my LinkedIn, so feel free to reach out. Yeah, and then and I unmuted it at that point. So, yeah, cool. Thanks, DSR. So yeah, feel free to reach out and get in touch with me through those as well. So who here is already using GitHub Actions? Cool. So majority of the people in the room, and I'm assuming that the majority of people probably online have at least used it in part. So for those that haven't, and just kind of as a starting point to refresh this, what are GitHub Actions? Fundamentally, GitHub Actions is GitHub's workflow engine. And it's important to think about it in that way because GitHub Actions are more than just CI/CD. So where we use it most of the time is to build our applications on PRs, to run our tests, to deploy it out into production. But actually any automation that you want to do within GitHub, basically you're going to do it through GitHub Actions. And the other thing to think about with it is that it's really the third generation of workflow CI/CD tooling. So who here had the privilege, misfortune of getting to use Jenkins? Bit of a bone in the throat there DSR. So a few hands going up on Jenkins. Jenkins was really that, like the thing that really kicked off the whole CI/CD process. I never got to use it directly. I only sort of used it alongside. But from what I understand, really, you kind of had to get in and you had to use a workflow designer to really design what you wanted to do. And it was primarily around scripts. Such a beautiful interface, Craig says. And then what we had is the whole revolution of, well, we need to move away from doing everything manually, doing things by GUIs, doing things through ClickOps, and we've got to do everything in code. And so then we get the GitLabs, we get Travis CI, we get these toolings coming in where now you're defining your workflows in a YAML file. But again, there's kind of limitations to that. And when you're doing it in a YAML file, and if what you end up having to do, if you want to do something, is something like this. You have to go and write scripts. And so this is a pretty simplistic example, but this is directly taken from a situation where I having to do something in a GitLab environment. And so, yes, I know in GitLab I can go and I can specify the container that I'm going to use, but the problem comes is I then need a container for this and a container for that and this and that, and it becomes a high cognitive load to remember what I'm doing in what place. But even then, that would only solve the first three of those problems of getting my Terraform binary onto my runner. I then need to remember what are my commands that I need to do? What do I need to run in order to build my application? What do I need to run to test my application? And then if I need to do it multiple times or we add functionality to the application, I need to remember to go up and update my CI/CD scripts to make sure that I'm picking everything up on the way through. And it's far better than trying to do it manually. But there's a limitation to all of that. And so what GitHub introduced with Actions was the concept of what's there in the name, Actions. These are reusable, composable components of a workflow that we can share. Remember, GitHub's built on open source. And so the whole point of GitHub Actions was to allow the people who are really good at writing things to write them once, and then for all the rest of us to consume them. And so in this scenario, we can take this, as I say, simplistic 5-line script, and I can turn it in, and I can turn it, I'll show you. But then if I do that, So this here was Terraform validation. So I can validate that what I'm doing works, but I want to take the output of that and turn it into a code review. I don't want to have to go and dig through the logs when my pipeline fails to work out why did it fail, what was wrong. I want to surface that up into my UI. So how do I take that from a script perspective? Now I've got to think about interacting with the GitHub API. And how do I do that? And I've got to get tokens, and I've got to this and that. It becomes really messy. I can take those 5 lines plus that question and turn it into this. Now, isn't that a lot simpler? One, to understand what's happening. We've got here at the start, sorry, wrong button. We've got here at the start a setup command. Go and get my Terraform version, and I can specify a specific version if I want to, or I can leave the defaults and get the latest version. And then I use an action that somebody else wrote. Well, that somebody was me in this scenario, but that somebody else wrote to go and validate. And I want it to create a review, so I just tell it, create a review, give it a token, my GitHub token, and I just need to make sure it has the right permissions. And that will go and generate a code review for me from my Terraform code. And I've not had to think about how to do that. Somebody else has done the heavy lifting for me. And so we get this reusability that comes within GitHub Actions. And that's the key to the success of Actions. We get it somewhat in Azure DevOps. Is anyone here used or using DevOps? Yeah, a few hands tentatively going up. But we get this with DevOps. There is the marketplace where you have to go beg, borrow, and bribe your DevOps admin to install a package for you into DevOps that then allows you to do this kind of a thing. That's great from an enterprise perspective and for limiting things, but it's not great from a rapid development side of things, is it? Whereas this here allows me to go out to reach out. Now, there's good and bad about that, and we'll talk a bit about that as we go through. But that's the key thing about Actions. The other thing to remember about GitHub Actions, if I go back a couple of slides, is that they're all driven by GitHub repository events. That's important to remember. They're driven by events that happen in and to your repositories. And that's powerful, but it also provides a significant limitation, and I'll talk about that as we go through. It's not an insurmountable limitation, but it does provide some level of limitation on that. That's the end of my PowerPoint. No, don't want to death by PowerPoint. What I want to do is kind of step you through some GitHub Actions to show you what they look like, to show how it works, and to talk through what we do and why we do the way that we do. So I'm sure those of you who are using Actions are familiar with. Those who haven't, we've got our special .github folder. Anything to do with GitHub that's GitHub specific is going to live inside that .github folder. So this is just a repo that I put together. It's public. You're very welcome to go and browse and steal and borrow and things from there. Within the GitHub folder, we've got a couple of common files, a labeler.yaml, and I'll talk about that one that I haven't got working because I only threw this together reasonably quickly, and our Dependabot YAML. So for those who aren't familiar with Dependabot, Dependabot is as part of the security suite of advanced security. It will analyze your code base, look for updates to your packages, to your dependencies, and raise pull requests for you automatically to bring them up to the latest versions. Any guesses as to what Dependabot runs on? GitHub Actions. So Dependabot is running on Actions for us from there. Inside our workflows folder, this is where our actual workflows live. So each YAML file is an individual job. None of the GitLab, here's one file and you've got to slam everything in. Trauma, I'm still not over that. You get one file here per workflow that you want to run. What you name them is entirely up to you. I've kind of done a little bit here around some naming conventions. So I've got my automation scripts. These are ones that are going to, as I mentioned, deal with workflow events, but they're not my CI/CD stuff. This is stuff about improving the quality of the developer experience around the code as it's happening, and I'll show you those. We've then got our CD deploy YAML. We've got our integration. We've got one for pull requests, and we've got one for a release. So again, we're thinking here that we want to be doing some testing when we have a pull request. And then once that's been approved, we've got to do some form of release management. How does that work? And then we've got a few down the bottom. We've got our code QL. Again, part of the the GitHub security suite that comes in. This will go and analyze the code that you've got in there and raise issues for you. One of the things that it will look at is actions. So you can get a security report on your actions from GitHub Actions, because that's what runs CodeQL. We've got a scorecard here. Again, same thing. This is part of the security side of things, and I'll talk a little bit about that towards the end, about how do we secure our actions, because I don't know how many of you saw in the news all of about 2 or 3 months ago, one of the most popular, or one very popular GitHub action managed to get backdoored from there. So we've got to think about how do we prevent that sort of thing from happening, and we'll talk about that as we go through. And then at the bottom here, I've got a template file. And again, this is part of this recomposable side of things. We want to make it really easy to take the same code and use it again and again, even inside our workflows. And so in this scenario, I'm only dealing with that within the repository. But if you put that in another repository inside your organization, you can then just reference that from your code in the same way that we would do any other reusable action and pull them in, so we can actually get consistency. Somebody in your organization for writing pipelines, and then you as the developers are able to consume them from templates and know that somebody's keeping them up to date and in accordance to best practices as well. Speeds your job up. Make sure we've got a better response out the back end as well. So let's have a quick look at some of these pipelines, and this will be familiar to you. What I might do is actually come over here. This here is not VS Code, and for those of you who are observant. From there, this is the reason for it is I'm sick of VS Code taking up gigabytes of memory on my laptop. I love VS Code, particularly for things like the dev containers that we've already talked about, but just for raw out editing, Z is far faster. But anyway, rant aside. So this here is my PR workflow. So we've called it at the top here, validate. So what this is going to do is, as I look here, every pipeline has a trigger or a set of triggers with the on keyword. So on this event, do something. And then we provide a list of events. So here we've just got a pull request event, and I could just leave it at that, on pull request, and then any time a pull request in the repository is opened, this is going to run. Or I can be selective like I have here and said, only when a pull request is opened against my main branch do I actually want to do this. So depending, again, on your development, are you doing trunk-based development? Are you doing long-lived branches in Gitflow? However you do this, you can set up different pipelines with different requirements and work our way through them. And so in this case, when I have a pull request open against the main branch, and then what permissions is my runner going to have by default? In this case, we're just giving it read access. So it can't do anything, it can't write anything unless we explicitly in a job say that we want to do more than that. And then we define our jobs. So our jobs, and again, this is all just standard YAML that we're defining it in. We have our validate job in this scenario. The name, I can call it whatever I want, but we use that as a reference around if we need to pass data between stages of the actions. In this scenario, because I need to give it write permissions, and that's because what I would be doing, and I haven't done it at this stage, I want to be able to write my code coverage report back so that I can get a code coverage report. I might also be doing a SAST scan, a static analysis scan on the code before I compile it or once it's compiled, and I want to upload the results of that into there. And so I need the ability to write back to, well, in either in this case, contents write means I can write back to the repo itself. So maybe I want to format and fix. So I'm going to run a linter, and Go is obviously very opinionated in what it does. So I can write it, tell it to go format, and then I can push that code back in. So I'm not going back to the developer and saying, hey, you forgot to format the code correctly. We just update it in the background. Or you could tell them that, no, you need to do that. Build the habit, whichever way. The other thing we might want to do, as I say, is to be able to write back to the pull request. So when it runs, I want to write the results of the test suite back into the pull request. And so if we were doing that, then what we do in our permissions is we just say for pull requests, we're going to give it write access also. And so our GitHub token, the token that's given to us just for this job, will then get that permission set. So we're trying to scope it down to a small amount of permissions as we can, while still being able to do what we need to do. And then we go through and we use a set of steps. And so we've got a combination here. The first one here is one you'll almost always see, which is actions checkout. And that means we're going to go and we're going to reach out to the actions checkout repository on GitHub. And we're going to look for an actions.yaml file, which is going to give us instructions about how this works. And there are two types of reusable actions that you can get from this. Some are written in JavaScript, and others are written to use a Docker container. 90% of the time, you probably don't care which one you're using. The only time you might care as to whether it's a Docker or a JavaScript action is those few situations where you are running maybe in a Docker container and you don't have Docker inception like we talked about with the Docker and Docker, and so you actually can't use a Docker action. It's about the only time you really care as to which way the person has written the action, but it's something that can be useful to know. And what you'll notice here is that what we're also doing is we're checking out a specific commit in this scenario. Now, historically, and what most people do, you'll see I've got it commented out there on the line above, is they'll use a tag at v4 at v4. Give me whatever commit the v4 tag points to. Now, that's nice and convenient because if a bug's found and it gets patched and it gets updated, next time it runs, I'm going to get it. But if somebody hijacks the action, like they did to TJ Actions, then the next time it runs, it's going to point to the malicious code and pull it down. And so from a security perspective, we're actually better off to pin versions to specific commits. And then I've just, in that scenario, added a comment on the end to say this is the version that I wanted to use. But that would get annoying to maintain, doesn't it? Because whenever somebody releases it, a new version, how am I going to know what needs to be updated? Well, let's introduce again our good friend, Dependabot. Dependabot supports actions dependencies. And so in this scenario here, this is bumping actions setup go from DCA8 commit to 7F17. Dependabot has gone out, seen that I've got an action, it's dependent on another version, a new version is available, here's the PR to update it. And if I had it across 12 of my workflows, I'm going to get one PR to update it across all of my workflows. Then I can go and validate that, yes, this is a non-malicious update. I'm happy with it. We run tests as part of it because it creates a pull request. So any of the pull request tests are going to come to see what's going to go on. Now, again, there's obviously that small risk in there that if it points to a malicious commit, it can still run, but you're not automatically upgrading things on the way past is the big one. And so that's the simplest way of making sure we stay up to date is leveraging Dependabot. And so this is that setup go action. So this again is written by the actions team. So they're the sorts of actions that I figure I can trust. And I can specify parameters like what version of Go in this scenario do I want to use. They'll have a default, but then I can be explicit about that. And then I have the ability to go and just run command lines as well. And the great thing about this is within a job, one job runs on one runner. And so what that means is every step in the job is going to run in the same context with the same code that you've used. So if you modify it in step 4, the modification you can use in step 8. If you generate an output of tests in step 6, you can upload the output of those tests in step 8, for example, because it's all there inside the code. It's not until you move to a new job that you get a whole new environment, clean and starting again, that you would then have to go and regenerate any artifacts on the way through. So again, it's convenient in that scenario. Build the application once and then run 2 or 3 different sets of tests at it from that same binary. Don't have to compile it multiple times. Or set up different workflows to do your different streams, get each of them to compile at once. Takes a little bit of run time up front, but now you can run them all at the same time across multiple actions runners and get a response back more quickly. So those are the trade-offs that you start to get to as you start to think through how to do this side of things on the way through. And from there, this is our pull request. And we can define in our branch policies to say, well, any pull request workflows must succeed before I'm able to merge my request. So if the tests fail, I can't merge. If our code QL inspection throws up high errors, high security errors, I can't merge. They need to be fixed before we do this. So again, this is, we know what CI is intended for. We know about that pull request workflow, what the intent is for that, and that's giving to us there. Okay, so we've done it. We've created our code. It looks good. It's been reviewed. Now we merge it. So what do? Well, now we move on to our deployment. So this here is a release pipeline. And so this one here has two on tasks. So we give it a name at the top. This one is to create a release. and I do this intentionally, and I'll explain why as we go through and where our gap falls in, because it's in the CD, the continuous deployment, is really where if there is a weakness of actions, we find it. But we find it in almost any workflow engine that is based upon repository events, because it can only trigger so far. And particularly if we're doing the right thing from development, which is build once and promote a binary artifact rather than building every time we deploy. If we build every time we deploy, we can run it off a system like this really easily. And then we introduce bugs into production because the tool chain changed for building on the way through. But if we promote a binary, how do we trigger that same binary to be the source of our deployment? And that's the weakness we have within of GitHub Actions, because it's based on repository events. We can deal with it with releases because we can trigger on a release. So there's ways around it, but it is kind of the bigger weakness there. So in this scenario here, we're talking about a push into main. So our events push to the main branch. Again, we could run it on any push, but particularly here we want to do it on main. And then we've got this fancy keyword at the bottom, a workflow dispatch. All that means is I can now also go into the portal and I can run this at a specific branch and a specific commit. So if I need to manually kick off a deployment for redeployment for whatever reason, somebody managed to go and delete production and we need to redeploy, if I've got a workflow dispatch, I can go in and I can just kick it off without actually having to trigger a specific event, a code update or anything like that in the repository. So really useful for testing side of things, and it kind of is a backup from there as well. Again, we set our permissions, our build. I didn't talk about the runs on. That's purely just what's our runner. Are we using a GitHub managed runner in this scenario running on Ubuntu? Are we running it on a specific runner group inside our network? So we can again define, well, I want to, when I get to deployment, I want to deploy to production, but I need to run on the runners that have access to deploy to production, not the ones that have access to deploy to dev. But conversely, when I deploy to dev, it needs to be on a dev runner so that I can't accidentally deploy that to production. So we can segregate that out, and that's a broader topic than we'll cover today. Again, we're going to check out our code. We're going to set up Go. We've seen this on the way past. We do our build. And in this scenario, we're doing an artifact upload. So we build once, upload a build artifact into GitHub. So we've now got a binary that we can actually use. Now, one thing to note about artifacts. Artifacts are downloadable by anyone who has read access to the repository. What that means is do not put a secret into an artifact. I come from an infrastructure as code background. I do a lot of Terraform, as you can see by the examples that I tend to use. Many people go, cool, I'm going to publish my Terraform plan as an artifact. Don't. Please don't. Because anyone who can read your repository can now get access to every secret that is stored in your state file. Because your Terraform plan file includes a copy of your state file. Do not put secrets into artifacts. There's no way, unlike GitLab, GitLab's really good in that scenario where it has the ability to control who can download artifacts. In GitHub, if you have read access to the repository, you can download the artifact. So don't put any secrets in artifacts. But what we can do is after building, and this is where our deployment comes in, we now here have, in this scenario, a workflow on creating a release. So I uploaded as an artifact there. The other way to do it is to publish a release. And so this is quite a common one. Let's publish a release. The binaries are all stored there. It's linked to a specific commit. And from that release, when that's created, we're going to trigger the creation of this. Actually, my mistake. I'm misreading my own code. You can do that. That's not how this one works. This one here is on a previous workflow run. So when a workflow run has completed, in this case, against the main branch, and it's our release workflow, then I'm going to trigger this one. Again, the point of that is to say, here's my artifact that I've built once. Now I'm going to trigger my deployments to my different environments. And so this here is where I now have multiple jobs. So the previous examples I've shown you, each run has a single job. A job by default, all jobs in a workflow by default will run at the same time unless you specify dependencies. So this is really good as well as you get into advanced builds, particularly when it comes to integration, because you can set up what's called a matrix build. And a matrix build, think of it this way. You specify 3 OSs, Windows, Mac OS, and Linux. You specify 2 architectures, AMD 64 and ARM 64. And then you ask GitHub, build me one of every combination of that target architecture. I don't have to specify all 12 combinations, or so 6 combinations. I just tell, these are my sets of combinations, go and build these, and it will spin up enough, one job per combination, but it's a really simple workflow to look at in that scenario. So it's the power that you can get into with that, and the fact that it'll run those jobs at the same time. But in this scenario, we want to deploy to dev, and then we want to deploy to production. And so this is where our needs keyword comes in. So in this scenario here, production depends on the successful run of dev. If dev fails to deploy, production won't deploy. Seems to make a lot of sense. What we also do is we're using an environment. And so GitHub has a concept of environments for a repository, and they can have different approval workflows. So when you go to deploy to an environment, it will ask you, or it'll ask the people who have been allowed to approve that to do it. Maybe production needs a specific team and that needs 2 approvers, but dev, anyone can approve. So we get to build these up and actually control our flow through without just randomly rolling it out all the way through. And then what we're seeing here is this users keyword. Because when we think about it, deployments are something that look almost identical, don't they? Just the difference is where it goes. And so this is where that template file comes in. So if we have a look at the template, this is a reusable workflow. And I've just called it that so that it stands out in my list of workflows. And this is where we have a special event, a workflow call. So what it says is this workflow will get called from other workflows. And then I specify a series of inputs. And in this scenario, because it's a simple example, I only want the name of an environment. So when we're looking at the deployment here, we use it with, and we specify the environment to be deployment. And so what we do is we go through here, and then we use that input to define our environment, and away we go from there. And then this is the other great thing that we can start to do is, again, some of these tools that are given to us are really, really powerful. So one of them that I use quite frequently is this GitHub script action. What it takes is a JavaScript script that is able to call out, or that is intended to interact with the GitHub API. It gives you, for those that are familiar with interacting with the GitHub API, it gives you a full OctoKit, already hydrated, already authenticated, ready to just use. I don't have to set it up. I don't have to think about it. I can just call that and then start interacting with the API using the token that I've got for my runner at that point in time. And so in this scenario here, what I'm doing is I'm going and listing the workflow artifacts because, again, this is where I said there's a weakness on dealing with binaries. I'm having to go back to my build workflow, find the artifact that it generated, and download it. And I have to do that with ugly API calls, but that's something somebody could actually kick out, turn that into a reusable script. Just feed me in the information which I care about, which is in this scenario, the run ID of the workflow that I want, and just give me the artifact back. So I could set that up, but in this case, I've written it myself. Or should I say I copied it from somewhere? Because that's what we do these days. No, sorry, AI is what we do these days, isn't it? And then this one here, I just unzip it because, again, just proving that this process will actually work from there. But this is where we can now build that complexity out and we can actually work through from there. But that's kind of all usual stuff. That's reacting to the repository events, that's building, that's deploying. We're used to that. Sure, we can use the reusable actions, but where else do actions make sense for me from here? And this is where I said about the cognitive load. For example, one of the big ones that Microsoft recommends that you look to do is you leverage their labeling bot. And that, therefore, is just an action that they provide you, actions labeler, that will, in this scenario here, whenever a pull request is opened up, whenever an issue is opened up, it will go through, look at, and from a pull request, look at who it is, like what files have been modified. Based on the files that have been modified, it will set a label. So for example, let's think you've got a mono repo and you've got your back-end code in one folder and your front-end code in another. Well, with the label bot, when somebody raises a pull request, it can go and label that back-end, front-end based on what got changed. Somebody doesn't have to come and look at it, work it out, and then assign a label. We've got to define the rules up front, but we can do that. Maybe it's the design files have changed, and so therefore we need to flag it with design because the designer is going to have a look at that. And that's the approval workflow it needs to go through is from the design team. Or maybe the infrastructure code has been changed, and so we need to get the platform team involved. Well, with the labelers, we can do that. We can run these commands on a pull request being created, add labels. We can assign it to a team. We can assign it to people. We can assign it to have specific reviewers. All of this automation, the stuff that normally somebody has to sit there and kind of work their way through and spend that time triaging, who needs to deal with this? Kick it over here, over here. If you can build rule sets up for it, actions will take care of that for you on the way past. But again, this particularly makes a lot of sense for open source projects where you've got contributors offering to commit who aren't part of the core team. Maybe not as important sometimes for a core team, but then you know who it is that actually has to look at it. One of the other big ones is the stale workflow. Again, one that's provided for us by GitHub, but you trigger this on a cron schedule, run it once a week, once a day, and it will go through and look for issues and pull requests that have been there for more than 30 days. And it will close them. Just with a comment of, this has become stale, you can get a warning, and it's all configurable about how it all works in terms of your dates and your times. But again, now no longer does somebody have to go through and go, hey, nobody's updated this in 14 days. Can we have an update on this? Is this still important? Oh, no, it's not. Let's close it off and close down our backlog issue. Again, two things. One, it's driven off repository events, or in this case, a cron schedule. But secondly, it's just leveraging those tools that have been given to us by the community to feed in to do this. And that's the great advantage of it there. Or you can have the fun one, which is, again, GitHub give you the first interaction. When somebody, and again, from an open source project, raises their first pull request, is there a process, a set of hoops that they need to jump through? Do you need them to sign a contributor license agreement? Do you need them to go through some form of process? Again, there's an action here. They create it. It looks at that, identifies it. I don't have to write any code to do this. I'm able to leverage what other people have done, and that's the power that we get with actions on the way through in terms of that. I think that's most of what I had to say. As I say, CodeQL works off the same side of things. I think at that stage also conscious of the fact that we are running close now. We're past 7:30. Were there any questions? As I say, it's a lot, like it was with the code spaces and Luke, a lot of information in a really short amount of time. But the intent was to kind of give an overview and an interaction of actions. Are there any questions from the room, from chat? think we put everybody to sleep is potentially the problem. Yep. Git leaks. I have, yes. Yep. No, Git leaks doesn't look into artifacts. And even GitHub Advanced Security is not looking at artifacts and the contents of artifacts in terms of that. They're more looking so Git leaks. For those that aren't familiar with Git leaks is a binary that's intended to be run as a pre-commit hook. So you run it. The intent is to run it on your machine when you're adding commits into into Git. And it will search for what looks like secrets and warn you that you're about to try and commit a secret. So before it ever gets up to GitHub, it's trying to prevent it from getting there in the first place. And I think you can run it against a code base to have a look at it from there. So you've got kind of both options. And then in GitHub Advanced Security, you've got the secret scanning, imaginative names, which will also go through and look through your code base and alert you if it finds, say you've uploaded your AWS API key. And depending on, and for certain organizations, it will, and certain types of secrets, it will actually notify the issuer. So for AWS, it will actually go and notify AWS that the key's been leaked. And the AWS will start a shutdown process on that as well. But again, that's only in the repository. It doesn't then extend out to the artifacts. And that's why a lot of people, they don't think through who's got access to the artifacts. That's the biggest challenge in that scenario from there. And in some situations, it might not be a big deal. You can weigh the risk up and go, you know what, our team who's got access to this would have access to get hold of those secrets anyway because they're able to read them from there. That they've got access to the artifact doesn't actually matter. So it's a call that you can make, but you need to be aware of it rather than just blindly making an assumption in terms of that. Question, best starting point for learning the basics of CI/CD, a new learner developing ASP.NET web projects and using GitHub for the repos. Anything targeted for .NET with GitHub would be appreciated. Broad question. I think the key things really are to kind of think through and look through what CI/CD is. There's and there are plenty of books, plenty of websites. I can't actually think of any of them off the top of my head. DSR might have some and be able to post and chat in terms of there. One of the best ways, and the way that I tend to learn with a lot of this, is actually to find open source projects that are using that tooling and see what they're doing. And particularly ones from larger organizations. Yeah, and as Luke says, Microsoft Learn has lots of modules around how to do CI/CD, how to do ASP.NET, your deployment side of things. But the problem is it becomes such a broad discussion point. I mean, to say CI/CD even in and of itself is a massive topic of discussion and debate and things from there. Find projects that are doing it well. Leverage tools like Microsoft Learn, and thanks Craig for linking there on the GitHub training as well. So the GitHub training there on Microsoft Learn, they're great opportunities and great places to start from there. And yeah, out of there, reach out and I can track down some of the books that are recommended. But I mean, again, have a look on Amazon for books and see what's well rated, because the stuff that lasts will bubble up to the top of Amazon searches and things like that as well. But find people who are doing things that you like and continue from there. Yeah. Was that? Yeah, I think there can be some good things in there, and it depends on how quickly you can pick stuff up. A lot of it will go. DevOps Handbook probably will go over the head of a new person into CI/CD. The other thing that I'd highly recommend, and this is just a much more general comment, is again if you're in an org where you're doing it, find somebody to attach to. Get close to, ask questions in your organization, ask them to show you what they're doing, explain what they're doing, and to help give you the opportunities and then to point you and guide you in the right direction. Because books are great. You can learn a lot from books. these sorts of talks are really good, and you can learn a lot from them as well. And there's no end of tutorials on YouTube, and some are good and some aren't quite so good. But the best way you'll find to learn is to actually get alongside, and this brings me back to my opening remarks of the importance of coming together when we can, and then taking the opportunity one to another to share. Because it's those sorts of questions, what I find useful might not work for everybody else, because I learn in a very different way to how other people learn. But the way I learn will work for some people because they learn in a similar style to me. So get alongside people, get a broad range of experience and understanding and perspectives, and go from there. And yeah, there's a whole stack of links coming through in the chat there as well in terms of that. Yeah. Not in the same job, but in the same workflow, yes. So every job has a runs-on definition. So if we have a look here, so in this case, our analyze job has a runs-on definition. Because each job runs in the same context, it has to run on the same runner. But if you have a workflow with multiple jobs, you can kick some out to GitHub runners. You can run some internally. You can run some on a Windows runner, some on an Ubuntu runner. You can mix and match them between jobs as you need to. The challenge really at that point just becomes how do you move data between them, and passing artifacts around is one way of achieving that. From there, upload an artifact in one job. Inside a workflow, it's really easy to get hold of an artifact from another job. It's when you're going cross workflows that you have to get messy with the scripting that I was doing. But I was doing that to kind of demonstrate the point of we want to promote a binary and then kick off a separate workflow from an event from there. But if you had your build as step one, job one, and then your deployments as jobs 2, 3, 4, 5, 6, you can pull the binary artifact from job one really simply into the other jobs. It's still the same binary that's being used, so you're only building once, but then you could be using different runners to deploy to dev because that might be a completely isolated environment. Test needs a different set of runners, and then production has a really locked down set of runners internal to the network, for example. So yes, you can run each job on a different runner. And then each workflow obviously is independent as well. Craig is asking, is it worthwhile pinning your actions via a hash rather than a release number? Well, the answer to that question, it really comes down to it is a management overhead. There is a risk that's been demonstrated recently on pinning division numbers, which is if an attacker manages to get right access to the repository, they can change a tag because that's all a release number is after the @ symbol. So if we have a look here. So in this scenario here, I've got an action with a tag, a v3. It's just a reference, but it's a movable reference because it's a tag. So anyone maliciously can move that tag to point to another release, or they can move it beneficially to point to an updated version. That's the advantage of using a tag is I don't have to keep it up to date. But the downside is with that ease comes the risk that if someone gets hold of access to that repository, they could then update that to point to a malicious commit, which is not a good thing from there. And that's what happened to TJ Actions a couple of months ago. And it was a long chain. It went back that they compromised somebody and used that to compromise another one, and it wasn't until it got to TJ Actions it got noticed because his actions are a very popular set of actions. So yeah, it's security versus usability trade-off. With Dependabot, the usability isn't too bad because Dependabot will tell you, hey, I've got a new version. You just have to be really, and the other advantage is at least the Dependabot, because the risk is, and just to nerd off now in terms of the whole what's going on, the issue was that compromised action leaked the GitHub token. And if the GitHub token has write permissions to something, that's how the attacker managed to get there all their way up to TJ Actions, is that they managed to compromise other actions that were being used on the way through. If that GitHub token is leaked, anything that GitHub token can do, a user is able, an attacker could also do. So if your GitHub token has write access to your repo, if an attacker can get it, they have write access to the repo. It is for literally minutes. So they have to be on it to be able to exploit it, but it's possible. With the Dependabot doing the upgrades, Dependabot is running with read access only. So at worst, they would get read access to your repo, but then to get the token out, it needs to be against a public repo because they need to be able to get to the logs. In a private repo, they can't get to the logs anyway, and so it's only a read token, so it could only actually get to whatever you have the public has access to anyway. So the risk is low using Dependabot on the way up as well.
How come Dependabot sometimes, like for my repos, I don't really use it, but because most of the services are internal services, so they're not. So if there's a security problem, I can just deal with that a bit later on because they're not exposed. But there are some things there are some public APIs that as soon as it comes up, I just deal with it myself. But because it doesn't seem to, the pull request doesn't work with Dependabot. It always has some permission problem. Have you experienced that?
With internal, because it needs to have, and if you have a look at the Dependabot documentation, for a private repo, there are configurations that you do need to set up in order for Dependabot to work in a private, in your private repos. And that's because by default, Dependabot's going to run on a public runner and is actually going to pull your code anonymously. It's not, so it needs to be able to authenticate to be able to pull your code. And then if it's checking and if you've got in things like that, so have a look at the documentation on Dependabot. That's what I'm guessing is probably the issue in that scenario.
But it's not a security because when it runs, access to
no.
Store. So
Yeah.
I just need to give it access and just
correct.
trust it.
Yeah, correct. And that becomes that risk in terms of Microsoft and GitHub is running these, and they're running them on their pool of Dependabot runners.
Yeah.
You're right.
It's unlikely that someone's going to hack into
correct.
Dependabot.
Yeah, correct. But again, it's not impossible, but the risk is low. But it's nothing is impossible at that point in terms of that, and we always end up with risk trade-offs on the way through in terms of that. I do vaguely recall an issue, I think many years in the past, where Dependabot did get compromised. I think that was either just before or just after GitHub purchased Dependabot. But it was something similar in the sense of somebody had managed to get their way in and implant some malicious code through a pull request process or something like that into Dependabot itself. But it was caught very quickly, but it did actually make it through a bit. So there is always a risk, and that's always the risk of open source. Is you use open source tooling, there is always a risk that somebody can get in and plant something malicious in the code, and we therefore have to be careful. Anything that we're using, open source, closed source, how do we trust where it's coming from? And that's really the big question, and that's kind of the risk in a sense of GitHub Actions. Is the temptation is to go and just find an action that somebody has written and go, cool, I can use that.
You're always going to check.
Yeah.
See what the hash on it, and then
absolutely.
So if you put the hash on it, then Dependabot's pretty risk-free, isn't it? Because you've got Dependabot's probably got so many checks for that.
Correct. And it's not getting write access to your because even in that scenario for a private, you're only giving it read access. You're not giving it write access back. You give it access to create a pull request, and this is where your risks come in, and it's
the secrets that the pull request
is correct. And so you have to be careful about what jobs you automatically trigger from there. And so again, some of those things is if you're going to do automatic deployments on PRs, you're probably best to have a pre-step that's checking for and do some work to say, is this a Dependabot request? If so, don't automatically trigger this. Get somebody to look at it. Or this is where you can now start to do things like, and it had to come up at some point, turn Copilot on and get Copilot to check every pull request on the way in. To do that before you then start thinking about, again, it's a once over. Is it going to be perfect? No. But if you've got Copilot licensing and it can go through and explain what's going on, it might pick something up on the way through that a human might miss on the way past as a review. Again, it's not a foolproof side of things, but being able to have Copilot come in and explain a pull request to you, what's going on, what is this code change, and I was talking to somebody earlier about this, that in some senses, Copilot is fantastic for that, because Copilot has absolutely no preconceived ideas about what the pull request ought to be doing, because it's just a machine. And so it's just literally looking at what the code does, whereas we get influenced by the description on the pull request. This will go and fix this by doing this. Cool. Oh, yeah, I see that it's fixing this by doing this. And I kind of skim over the rest of what's going on because it's doing what I was expecting it to do. And I didn't look closely at all the rest of the stuff that was also going on. So that's where AI can actually be quite useful, because it doesn't come in with those preconceptions that we might.